set. It's working. Okay. So we've talked a lot about slope-intercept, standard form, where x and y are on the same side of the equal sign.
But we have to do this. And like one of our homework.
Yeah, this you have to do this in tonight's homework, I believe.
But we had to do this earlier.
You did, really?
Like way earlier when we first learned graphing, there was like one. You gave us a worksheet for the last problem. One of the last problems had that. Oh,
maybe. I can't remember. See,
maybe?
I can't remember. So maybe I did. I don't, but if I did, then you guys will know it really well. But and then point slope form, right? But this is going to be where all of those were ones where there was a slope, right? There was something like there was an x. You had y equals something x plus something, usually, right? So you had y equals mx plus b, right? mx plus b. So you had, for example, y equals 2x plus 3. So this, because there's an x and because there is a 2 in front of it, there's going to be constant variation. Because every time, y is going to change every time you have a new x, right? Right? Even if I didn't even have the 2, because then it would be 1x plus 3. Y is going to change each time I change the x. So it's going to constantly be going upwards or downwards. It's always going to be sloping, right? Now, what if I didn't have that x at all? And I just had the b. Y equals 3, right? So we're going to draw.
It's anywhere on the. It's a line that would just be on the 3.
Yes. So here's my y-axis. Here's my x-axis. It's saying y is 3. Y is always 3. No matter where I am in the universe, y is 3. There is no way getting around that. It says y equals 3, right? That's it. Y is 3. 1, 2, 3. Okay, so when I'm here right now, y is 3 right here. But when I'm in Timbuktu, Timbuktu is way over here. What is y?
3.
Y. Y is 3. So it doesn't matter where I am, right? It says y is 3, so I got to put a dot over here. But then I go to Kenya, Africa. That's way over here. Y is still 3. Oh, okay. So I put that. Oh my gosh, look at that.
It's a straight line.
It's a horizontal line. Now, as a kid, and even as a math teacher, when I see y equals 3, my brain thinks y, vertical, right? Y is the vertical axis, so y equals 3 obviously is going to be a vertical line. No, it isn't. It isn't. It's a horizontal line. So that's
and that means that x is a vertical line?
So now let's
So
do...
wait, Gary, it
Yes.
is a horizontal line, and you can have any x, but as long as y is 3, it is for in this
If
case.
you have an x, then it would not be
No,
horizontal.
but the way you did it, it's still on the graph. So like the points that you did for like Timbuktu and Kenya are
Oh, I see. Right.
Yeah.
Right. So it doesn't matter what the x is because x doesn't change. It won't change. Y is not dependent on x.
No, but what I'm saying is it can be any the x. Like if you were to write it as a point, x can be anything as long as y is 3.
Yes.
For that. Okay.
Yes. Right. Exactly. So now let's say I did in a different color. Let's say we did. Let's graph y is equal to negative 5. All right, so here's 0, right? So 1, 2, 3, 4, 5. Y is equal to negative 5. Even in Kenya, Africa, y is equal to negative 5. And even in Timbuktu, y is equal to negative 5. Therefore, it's going to be a straight horizontal line.
How do you get it vertical?
Ah,
X.
instead of y,
Oh.
we have x. So let's use a different color for x. We have x. That's not a good one. We have x, it's a little better, is equal to negative 7. Okay? So here's my x-axis. I go 1, 2, 3, 4, 5, 6, 7, and I put a dot. Now in Antarctica, right? It's also x is negative 7.
And
So, but in the Arctic Circle, y is also negative 7. Look at that. Got a vertical
Oh man,
line.
that's crazy.
Isn't that cool? Does that make sense? So when I see just x equals a number, I think, well, x is always that number, no matter where I am in the graph. X is always that number. Always that number. So it's going to be a long vertical line. And then when it's at y is equal to a number, it's going to be a long horizontal line. Always at that one place, yes.
I think I did this last night, so I have to be less than 50.
I think that's probably right. 'Cause,
Keep doing that.
that's probably what happened. Now, sometimes,
I did all the homework.
now what if, I know this is now, okay, so you guys understand this, right? Isn't it fairly clear?
Yep.
Right? And it's just weird. You have to remember that when it says x equals a number, like x equals 10, I think in my brain, x-axis, I think horizontal. It's vertical. Right? X equals 10 is a vertical line. Y equals 17. I immediately think it's vertical. No. I go up to 17 and it's horizontal. It's just weird. But that's the way it is. Now, I'm going to do one last thing, if I can find my eraser. And this is not horizontal or vertical, but I just want to see. I've given you full equations, but what if I gave you something like this? Y equals negative x. How would you graph that? What is it written in? What form is it in?
It's just,
What form is it in?
Oh,
It's written in this form.
y equals
Y equals
mx plus b.
Okay, what is my b? What is my b?
0.
0. B is 0.
And it's negative 1 over 1.
So I'm immediately going to go to 0 and put a dot.
And then it's negative 1 over 1.
And yes, my slope is negative 1 over 1. Right? Domenica, get that? Negative x means negative 1 over 1. So from my 0 y-intercept, I'm going to go over 1, down 1,
No.
put a dot.
Gary, how'd you get the negative?
Because that's what the problem was.
But you said it was y equals
Negative x. And I'm just plugging in the invisible 1 that's in front of the negative.
Gary.
Right? Yeah.
So you go negative this way and that way.
Gary,
You do that.
That works.
Negative down and then right on the
What did I just do? Oh, sorry.
Yeah.
Sorry.
Then it would just be like that.
What did I just do?
You
Oh,
just
okay,
ran
you're right.
negative.
I'm sorry. I did it wrong. Sorry. Jeez, thank you for catching that. So you fall 1, and then you run always to the right. So it's going to look like that. And then from here, fall 1, run to the right. Fall 1, run to the right. Fall 1, run to the right. Right? So that's how you graph that. So that is y is equal to negative x. So what if I did y? Let's do this in red.
X is equal to negative 1.
Let's say y is equal to x. What would that look like?
It'd be the same, only there would be a negative sign.
It'd be the same.
Negative.
It's still,
It'd
what's
be
my,
the same, only it would be
Plus,
going
it's plus 0.
up.
yeah, my
instead of
b
down.
is still
And
0.
then it'd be 1, up 1
It's
over
going to be
1.
1 over 1.
Yeah.
1, up 1 over 1.
So it'd be the
Up
same,
one,
only it'd be going
over
in a
one.
different direction.
Yeah, exactly. Look at that.
Oh my.
So that's how you get a perfect x with a graph. You graph y equals x, and then you graph y equals negative x, and you have a perfect x. Whoopee! Right?
Oh,
Okay,
good.
that's it. That's it for today. Pretty soon, actually, let me explain a couple things.
Good, I would need a perfect.
Very soon, I believe, actually, in the next, I don't know whether it's in this section, I think it's in, I think next week's homework, we're going to get into systems of equations, which is a big thing. It's real important. All right, that's it.
Really big. They didn't know at one